Distinguished audience, I will present the study titled A VR System to Assess Stereopsis with Visual Stimulation, a pilot study of system configuration. Contents: Introduction, Methods and Materials, Description of the study, Results, Conclusions, and Future works. The technologies and methodologies implemented in the aviation industry have made it possible to guarantee aviation safety to the world. Human factors and their interaction have become major challenges for air operations. These factors include sensory perception, specifically vision. One of the human factors that can influence in the aviation safety is the lack of stereoscopic vision. The stereoscopic vision is the perception of depth or binocular vision. This means if one of the two eyes is not functioning, it affects the depth perception accuracy. The visual capacity confers functional benefits in the development of daily tasks that are related to eye-hand coordination, such as pour water into a glass, park a car, pilot an aircraft, see space in 3 dimensions, etc. Related previous works have used different traditional methods and tests to assess stereoscopic vision. The virtual reality devices and convergent technologies have not been used to assess visual impairments such as stereoscopic vision. Our goal is to perform early detection of visual impairments related to stereoscopic vision in order to mitigate incidents during air operations performed by pilots of the Ecuador Armed Forces. We are going to present a virtual and functional task under an experimental condition, which consisted in the visual simulation while the participants went through a maze. Methods and materials. Now we can see the architecture of the VR system SAS. The VR engine includes a virtual environment and a virtual task assessment. For the interaction with the virtual environment, a wireless control or gamepad was used. The visualization device used was a head-mounted display Oculus Rift. This VR device includes motion sensors, surrounding sound, and 360 degrees vision. These elements allow to feel immersion within the virtual environment. The methodology used for the VR system design is based on the proposal by FENCOT. It includes the following phases: requirements specification, conceptual modeling. All the objects from the real model that will integrate the virtual environment have been defined and gathered. Structural modeling. The graphical model was structured including the 3D objects and the environment with their characteristics and their interrelations. Building and enhancing. We created the virtual environment and 3D objects and enhanced it with texture, lighting, sound, and interaction. The research team of the BC Stereo Diagnostic Project was in charge of the design and development of the virtual environment. In the image on the left, you can see the external view, and in the image on the right, you can see the internal view of the virtual environment. A first-person avatar was designed. This represents the participant in the virtual environment. The VE consists of a virtual maze with 12 intersections. The design of the virtual environment included 5 3D objects: a bomb, a flashlight, munitions, a military helmet, and a bat. They were placed following the sequence on the left side of the path. Description of the study. In these pictures, we can see the participants performing the virtual task. The total of participants for the experimental study were 20. Group 1 were participants without experience, and Group 2 were participants with experience. The administrative and logistical procedures were made for two groups of military pilots to participate in the experimental study. This is the scheme of the experimental study. All participants were informed in writing about the aims and procedures of the study. They also signed an informed consent form. Participants performed two stages in each experimental task. The first questionnaire administered was the personal data questionnaire and was filled out per each participant previous to the task. Afterwards, they were checked for stereopsis using the lung stereo test card 1 and 2. Then, the participants performed the experimental task. Each participant was instructed about how to use the devices, such as the head-mounted display and gamepad. The participant was also urged to pay attention at each stage of the task, as well as to remember the objects of the environment. Furthermore, the assessed variables were recorded. Finally, when they had finished the task, they completed the questionnaire to know how their perceptions about 3D sensations and satisfaction. This is a video demo about this study. Results. This section presents the analysis of the data collected from this study. Statistically significant differences were not found between both groups when the performance between the lung stereo test and the virtual system SAS was compared. This means that the virtual test and the traditional test correlate the results and demonstrate the validity of the virtual system SAS. The questions can be seen below the graph. Also, statistically significant differences were not found between the two groups in all four questions about 3D sensations. Overall, the HMD Oculus Rift allowed the participants in both groups to feel a more immersive experience, have better depth perception, and view 3D objects inside the virtual environment. To determine the outcomes for satisfaction, the participants answered questions 5 and 6 after their exposure to the virtual environment using visual stimulation with the HMD Oculus Rift. Also, statistically significant differences were not found between Group 1 and Group 2 in all two questions. In addition, the participants of both groups stated that this tool could be useful for the training which pilots need to carry out permanently. 19 out of 20 affirmed they will participate again and had a good time when they carried out the virtual test. Conclusions. A VR system combining immersion and interaction was designed and implemented. A virtual environment and 3D objects were created. A virtual task was defined, which included two stages, habituation and testing. The features of the HMD Oculus Rift used are very helpful because it allows to feel immersion within the virtual environment. The VR system SAS and the lung stereo test correlate and suggest that our system is valid to assess stereopsis. The results have shown that the VR system can be a valid, useful, and complementary tool to assess deficiencies in stereoscopic vision. In related to the 3D sensations and satisfaction, the participants were satisfied with our VR system. The use of virtual reality in this work is a technological, safe alternative because it allows to assess the stereoscopic vision in a simulated environment like if it was real, without compromising the user's safety. To continue with the development of the viewer system and carry out other studies that include the comparison between HMDs of other models and brands, to study stereopsis in other professions such as surgeons and drivers, and adapt different types of locomotion and interaction. Thank you.